course to steer is more proactive. So this is you're in the pub, you're like, right, the next pub in the crawl is over there. So how are we going to get there? And so we need to plot our route so that we go fastest possible way to the next pub. I don't know why I'm said pub too many times there, but so a course to steer. So, in fact, hang on, before we nip straight into that, so I'm just going to actually, no, it's all right, it's good. We will start with it. So the difference is here. So we've got our starting point. So the same as an estimated position is that we know where we're starting from. So that's about where the similarities end. Okay, so the first stage is always going to be plot your starting point. With an EP, we would then work out about, okay, what course have we steered, and we would plot our dead reckoning. But we don't do anything to do with dead reckoning really on a CTS. So we're now going to find, right, where's our waypoint? Where do we want to get to? So we're going to plot our waypoint, and then we're going to measure the distance between them, just as a kind of reference. Okay, and then once we've got our distance, we're going to draw a line between the two, and that is what our course over ground will be. So at the end of our course to steer, the boat will travel along that line. It's unlikely to be pointing directly along that line, but it's going to be travelling along that line, depending on the tide, wind, etc. Okay. So yeah, so we've drawn that on, and the key as well, and the key point to make is make sure this is a deliberate. I've drawn my line through it, and I've gone beyond it, and that's on purpose, because we're going to, depending on every situation, but it's normally useful to have it too long, and that will become apparent shortly. Okay. So once we've got that on, so this is obviously, I've just done a very quick, this is 10 minutes has just been spent working out what's the tidal hour in, okay, what's the tidal diamond I'm using, great, and what's my tidal stream, etc., all converted, time zone changing, blah, blah, blah. And so I've plotted my tidal stream. Now this time I'm plotting the tide on at the beginning, not at the end. Yeah, so at the end is for an EP, for the afterthought, whereas course to steer, we're plotting it on at the beginning because we're assuming that this much tide is going to affect us during the duration of this course. Okay, so once we've plotted it on, then the final line is going to obviously be completing the triangle. But where are we going to draw that line to, and what is the significance of the final line?
Gives you the course to steer.
So yeah, so it's going to give us the course to steer, correct? Okay, but how do we know where to draw it?
From the end of the tidal stream to your waypoint?
That would be nice, wouldn't it? It'd be lovely if we could just draw it straight to the waypoint. But that seems too easy, doesn't it? And that's because it is
the same time length for the course for your speed through the water and the tidal stream.
Is it like the repose, like the complete opposite?
Ooh, so I think I'm following you, James, there. Sorry, Dave, not following what you're saying there. Say again.
So if the tidal stream is going to knock you this way, would you do the exact opposite, the exact same distance?
No.
No. Right.
So when we're going, so we're choosing, right? We're choosing where we want to get to. What else can we choose if we're planning this ahead of time? What can we adjust in our in this situation when we go to sea? I mean, we can only adjust it to a certain point depending on what kind of boat we're on and how windy it is, etc. But our speed, so the boat speed that we're going to travel through the water, and now boat speed versus speed over ground are going to be two key points of this. So don't get them muddled, because our speed through the water we get to decide. The speed over ground is going to be decided by that plus the tidal vector. Okay, so whatever our boat speed is going to be. So for example, picture this. So basically, we're now going to plot our boat speed on from the end of the tide and wherever that intersects is. So here, my boat speed has intersected the course over ground beyond the waypoint, for example. So if I'm going to choose okay, just to say, right, this is a 5-mile journey, okay, or let's say 6-mile journey. Let's say it's a six miles from start to finish point, okay. I've got the tide is kind of with me a little bit, with and across, and I'm traveling at 6 knots of boat speed. So if I've got 6 knots of boat speed, this line will be 6 miles long. If this is all over an hour's time period, okay. And so picture this. So picture, okay, if this is 6 knots, if this is only going to be, in fact, I think I can annotate. I've just learnt this. If I was going to be only traveling at, let's say, 4 knots, is my angle going to be a steeper angle, so pointing more towards the north, or is it going to be a shallower angle pointing towards the east?
More shallow.
Yeah, it's going to be shallow. So if for example, if I'm in a really slow boat, I'm going to be pointing this kind of course here because the tide is going to be quite strong in comparison to my boat speed. Whereas,
sorry, Rory. How did you know how long the tidal stream line is?
I invented it in this situation.
Yeah, but I think it's important to say, because the point is that tidal stream line is, let's say it's for an hour.
Yeah.
So say tidal stream is 2 knots, that'll be 2 miles long. But then you use the same time period for your boat speed.
Yeah, exactly. So for example, if these two arrows,
it's not some random length.
No.
If it was very long, your line would be in a very different place, wouldn't it? On your course over ground.
Yeah. So for example, you can imagine. So in this situation, so I've got an hour's worth of tide and an hour's worth of boat speed, and then if I were to have, for example, half an hour's worth of tide. So I've taken half the length of my line, and I'm going to take half my boat speed as well. I'm still going to end up with the same angle to steer. Okay, it's all going to be, they're going to stay parallel to each other. So we'll come to that. But yes, and so also, if we say, for example, my tidal vector was really short, so I'm going to put this. So this, say, for example, I've just got that much tide. Then if my 6 knots of boat speed for the hour is that, then you can see the angle is going to be considerably shallower, and it's not going to be as different from what the course over ground would be.
So if you had the same tide in a boat that could do 12 knots, that would be back to normal, wouldn't it?
So, yeah, so don't worry, we'll come on to more examples of this. I'm just going to get rid of my annotations. Cool. So yeah, so that's the value. So yeah, as James says, we always work out, if we're assuming that this is a 10 o'clock start and we're aiming, we're traveling 6 miles. And we're traveling, if it's 6 miles to get here and we're traveling at 6 knots, we're going to assume that this journey will take us an hour-ish. Yeah. We then find out, right, okay, what is the tide doing for this hour? The tide happens to be on 150 degrees, let's say for 2.5 knots. Okay, so it's like, great, okay, 2.5 knots of tide, 150 degrees. I then apply my 6 knots of boat speed, and it's like, oh, well, actually, this intersect point is key, because what does that represent? So this here represents my arrival time. So it's going to take me, because this is all, again, based on an hour. This intersection point here is 1 hour. So in 1 hour, I will travel from here to the intersect. So therefore, the waypoint is going to be quicker to arrive at. So it's going to take me less than an hour to get there. Okay, if I was only going to be, if I say I only had 4 knots of boat speed, for example, and this is my intersect point here, then it's going to take me just over an hour to arrive at my waypoint. Because the length of this line is 4 miles long rather than 6 miles long. Okay. And so basically, so from this is also, so the importance of this is the kind of the important line, and this is the one where mistakes get made, is it's not only is it our boat speed, but it then also represents the angle of it represents our course to steer. So this is the course to steer that we will be steering from the start point. So the boat will actually be facing. Sorry, I should just stick with the arrows on. The boat will actually be facing this way as it moves along this. Sorry, they should all be the same angle. I just can't draw. As it moves across this line. So it's going to crab sideways into the tide. Okay. So we can measure that angle, and it's going to give us our course to steer in true. Okay, and then if we wanted it to... go away. So, and then if we want, so once we've measured this true angle, we can then use our true virgins or vegans, was it? I can't make delightful and lovely company. Make lovely, delightful company is what I meant to say there. So we see. So here, for example, so. If my true course to steer was 70 degrees true, I want to find out what is my compass course to steer. Sorry, I'll move the... There we go. So my variation is 6 degrees west. I have leeway, because remember, so leeway can be before or after the magnetic. It doesn't really matter. I have 10 degrees of leeway, and I'm on a port tack. So this time, because I'm on a port tack, so if we imagine we're sailing along this line, we're on the port tack, kind of heading upwind, let's say on a close reach, for example. I need to now take that 10 degrees of leeway into consideration. So I don't want the wind to blow me 10 degrees off course. I want to assume that I'm going to be blown off course. So I'm going to steer 10 degrees into the wind. Okay, and so I'm going to subtract 10 degrees on port tack, and that's going to give me 66 magnetic. And then I have 5 degrees of deviation. And so the key with this is that deviation is always the last thing you implement. Okay, and that gives us 61 degrees compass. Are we?
So Rory, you deal with the leeway in the opposite way you deal with it on estimated position.
Kind of, yes. In an estimated position, leeway comes in at the end.
Yeah.
Whereas in this, leeway just needs to come in before deviation.
Yeah. Yes.
Okay.
Sorry, did you minus the leeway there? I thought port was plus.
On an estimated position, port leeway is plus.
Yeah.
On a course to steer, port is minus. So it's kind
Not
of like
too easy otherwise.
they're kind of like it's kind of like another cadet. Yeah. So if you're on an estimated position and you're on a port tack, you plus the leeway, and therefore you can work out, right, if I'm on starboard tack on an EP, I subtract, and then they swap over and they reverse for a course to steer.
Are you recording this, Rory?
I am, yes.
Great.
So where did you get the heading direction, the 70 degrees true?
I've measured this bearing using my plotter.
Yeah, but like why 70? Like if you wanted to go to the lighthouse, wouldn't you adjust that angle so that you could go to the lighthouse?
No, because this angle is going to take me to the cardinal mark here.
Cardinal.
Oh, cardinal.
If I were to point, yeah, basically the length of this line is your speed, and so as long as that intersects your line, doesn't matter where it intersects your line, but that is going to result in you travelling, in theory, along this line.
Can I ask a stupid question?
Yeah.
If you're sailing a boat that you didn't know, how would you know your speed?
Well, you've got a speed gauge, you've got an engine, you've got, if it's you kind of guesstimate it. Like if you're on a 40-foot racy boat, you might say 7-8 knots. If you're on a slow little pop, 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 you might go 4 knots. If you're on something faster. So obviously, it depends. There's a lot of variables in it, in terms of the accuracy. Can you steer a steady course at the same speed? things like that. So there are going to be there's room for error in a lot of this, but it's still
There's room for error in a lot of it, apart from our answers.
So, Steph, does that make sense? So basically, the faster
sense.
it does, yeah. Yeah, cool. So now, what else we can find out is we know several distances. So from where we started and where we're trying to get to, we can measure that distance, and that is what we call our distance. Yeah, so that's our distance to travel. This intersect point, from our starting point, is where we're going to arrive in that time frame. So again, if it's an hour, for example, if we've travelled, we're going to travel 5.2 nautical miles in an hour, then that means that our speed over ground is 5.2. Okay, our distance is 4.4. So from start to finish, from our starting point to our waypoint is 4.4 miles, and the speed that we're traveling there is 5.2. So actually, when it comes to working out how long it's going to take you to get there, your boat speed doesn't matter anymore, because now what matters is your resultant speed using the tide and boat speed, and that is our speed over ground. So we can work out our ETA. So we think, okay, if this is going to take me an hour to get there, so speed equals distance over time, time equals distance over speed, okay? And because the speed is in, it's nautical miles per hour, if you want to get it in minutes, you just need to times it by 60. So the duration of our passage, or our ETA at the cardinal mark, is going to be 4.4 miles distance divided by 5.2 miles in speed, times it by 60, and it says 51 minutes. And that makes sense, because if we're going to take an hour to arrive here, we would expect it's going to take a little chunk less to arrive at the waypoint.